Gudimettla. You're muted, Jagan. It's good to see you. I haven't seen you for a while. I think last time I saw you, we were out in maybe over in Barstow, down in that area, with the Mobile Concrete Technology Center. So, and let's see. So I'm just going to give you a quick introduction here, and then I'm going to let you run. Make sure your slides come up okay here. Jagan is a project manager with the Mobile Concrete Technology Center for the FHWA. He's got a wealth of knowledge about concrete. He understands these things that Tyler was just talking about really well, and he works to implement throughout the country. He was recently out in Las Vegas last year and also over in California with the trailer. I guess we're calling it a technology center now. So Jagan currently works as the project manager for the FHWA's Mobile Concrete Technology Center. He has been working as a consultant for the FHWA since 2003. Work has taken him to all 50 states where he demonstrated new technologies and best practices to transportation professionals from agencies, industry, and academia. His areas of interest include quality assurance, advanced material testing, non-destructive testing, and pavement design. Jagan received his master's degree in pavements materials from Auburn University, and he's a registered professional engineer in Virginia, Maryland, and California. So, Jagan, thank you very much for joining us this morning. Really excited to see what you have to share with us, and I'm thankful that you're here with us. Are you having a little screen jumping around there? Maybe.
Can you see my screen?
I don't see your screen.
No.
So sometimes that's just make sure you're sharing the application window. I still don't. Okay, there it goes. So I'm just going to remind everybody, I'm sure you figured this out, but maximize the presentation window to see the details. And I'm going to turn it over to you, Jagan. Thanks again for joining us.
Sure. Well, first of all, hello to everyone. I'm really pumped. Anytime you hear Tyler present, you just get goosebumps. First of all, thank you, Charles, for inviting me to this conference. My presentation today is on a concept called maturity. It's basically used to assess in-place strength of concrete. It's really not a new technology. It's been there for a long time, actually. But unfortunately, even though it's been there for a while and it offers a lot of benefits, it's really underutilized. We didn't really take good advantage of it as much as we should. With the Concrete Technology Center, we have been promoting this technology for well over 25 years. One cool thing about this technology now is, even though the concept is still the same, we have new sensors come along the way in recent years, which actually really help us in advancing this approach. So with that said, let me jump into the presentation. So here is the outline of my presentation. We have different topics, and I'm going to go through each of these topics. The first thing is opening to traffic strength. So when is it really okay to drive? In this particular case, this is a brand new pavement, and apparently somebody drove a little too sooner. A lot of cases, what really happens is, we actually end up waiting a lot longer than we really have to. So, going on to the, opening the pavements to traffic sooner, a lot sooner or a lot later, either one is not a good thing. So what do we, how do we address this? Well, there are two basic questions that need to be addressed. The first question is, what strength do we really need to have? So with respect to that, it depends on a lot of things. It depends on the traffic. It depends on the pavement thickness. A lot of different factors can influence the strength that's needed. Okay, but if you look at agencies across the country, you can't really have one requirement for one particular pavement or one particular condition, right? So what most agencies do is they would have an opening to strength, construction traffic strength requirement. So here is a list of different states that I pulled at random, that shows their strength requirement. As you could see, some of them have compression requirements, some of them have flexure requirements, and then some of them have a combination of strength and time. So the interesting thing here is that it's not the same number that's used across the country. Every state uses their own number based on their own experience and based on their own materials. Okay, so we really are not here to talk so much about the strength that's needed to open to traffic, but more about the second question, which is how do we measure it? How do we know the pavement actually has the strength that we're looking for? Okay, now, well, it depends on the specification. Now, in most states, the strength is determined based on breaking either cylinders or beams that are primarily field cured. In some cases, people do use lab cured beams or cylinders, but most of the time it really is field cured cylinders. So the assumption here is when we break a beam or a cylinder, we are assuming that the beam strength or the cylinder strength would represent the strength of the in-place pavement or the structure, right? But is it really the case? The answer is no, because of a couple of reasons. Number one, when you have a beam, right, the beam is a much smaller mass of concrete or a cylinder is versus what the pavement is or what the structure is. So what really happens is the pavement or the structure gains strength a lot faster because of the excess amount of heat of hydration because of the huge mass of concrete, and typically the structure of the pavement gains strength a lot faster than the beam or cylinder would ever would. And secondly, if you're using lab cured beams or cylinders, that's even worse because the weather conditions or the curing temperature that the structure or the pavement is being exposed to is completely different than lab cured beams or cylinders, which are typically exposed to the same temperature throughout. So in reality, we are using these cylinders and beams and assuming that it represents the pavement, but it really is not. So, well, what can we do about it? Well, there are two different concepts that we could use to determine the in-place strength of concrete. One of the concept is maturity, and then the other one is match cure. Now, match cure is also a very good concept similar to maturity, but it's really not conducive or convenient to use it for paving applications. It's used a lot of times in the precast industry. So today our discussion really is on maturity. So what is maturity? Well, so let's look into the concept of it. It is a non-destructive test. It's an early age test. The cool thing about maturity is it's real time. We can actually determine at any given time the in-place strength of concrete. I mean, I think that's really the cool thing with maturity. It is relatively accurate. It is very economical in terms of use of it and just applicability of it. Now, one thing to keep in mind is it is not a 28-day strength test, which means you can't really use it for acceptance. Okay, so the cylinders, the beams that you make for acceptance, they're different than the maturity cylinders or beams that we make for opening to traffic. Now, the technology itself is really matured. It's been there. I think it was first proposed in the early 50s. It did become an ASTM standard in 1987. So it's been around for a while, actually. It's actually a very simple procedure. All we're really trying to do is we're trying to measure time and temperature of the concrete in question. And, we use a series of mathematical equations or simple equations that we actually, as users, do not need to get into. The software, with these sensors can actually get some of this work done for us. Now, in terms of the mathematical equation that I just mentioned, there are two different approaches for this. One is called Nursol, and then the other one is called Arrhenius. Nursol is the most widely used. It's the most popular one. It's relatively easy to use. So the presentation that I'm doing today is mostly based on the Nursol concept. So before we jump into maturity, okay, let's first discuss, how does age and curing temperature impact strength gain? Just based on our experience, we all know that as concrete ages, right, it gains more strength. Similarly, if you cure concrete, different temperatures, the higher the temperature, the higher the heat gain is. As you could see in this particular graph here, the concrete that's at cured at 100 degrees has significantly more strength than the concrete that's at cured either at 73 or 50 degrees F. Now, what really maturity does is it quantifies the impact of both age, which is time, and temperature, the curing temperature, it quantifies both of those, and basically it sees how both of these impacts strength gain, and that's all it really is. So let's assume that we have concrete that's exposed to cold weather, okay, and then all we're really doing is measuring time and temperature, okay, and similarly we also have concrete that's exposed to hot weather. So again, similarly, we are also measuring time and temperature. So when we measure the area under the time temperature curve, okay, and let's say that area, we give it a name called M, which stands for maturity. As long as the area under the curve of time and temperature are the same for these two concretes that are exposed to two different weather conditions, for the same concrete mixture, their strengths should also be the same. I mean, that's really what maturity is all about. So in essence, the concrete that's exposed to colder weather would actually take a little longer than same concrete that's exposed to higher temperature to get to the same strength. And that's really all it really is. So again, maturity is nothing but measuring time and temperature. So let's take a graph and let's say we measure time and temperature of a pavement in any pavement, and we measure the area under the curve. And to measure the area under the curve, we have this equation. Okay, all again we're doing is measuring time and temperature. Now the time you see here at the bottom, which says TO, is something called the datum temperature. It's a temperature below which the assumption is that there's no hydration taking place or there's no strength gain taking place. So we only measure temperature above this datum temperature, which is represented by TO here. So we'll talk about that in a little bit later on. But the idea with maturity is that it doesn't matter how you condition your specimens, whether they could be lab or whether they could be field. As long as the area under the curve, the time temperature curve is the same, which means if their maturity is the same, the strength should also be the same. So how does it work? So, I mean, that's the concept, right? So how does it work? Well, this slide in a nutshell shows the overall procedure with maturity. So basically what we do is we make a bunch of cylinders, anywhere from 12 to 15 cylinders. And in one of the cylinder, we put in a temperature sensor, okay? So this particular sensor measures temperature. It also measures time. So what the sensor does is not only does it measure time and temperature, but it can also calculate the area under the curve that I showed in the previous slide. So once we do that, then what we do is we break the cylinders at different intervals of time. Let's say at day 1, day 2, day 3, and it could be up to day 14. So each time we break the cylinders, we also measure the corresponding maturity number from the sensor in one of the cylinders that we placed. So using that information, we plot a curve between maturity and strength. As you could see, on the left-hand bottom side, you could see the curve. And that curve is called the calibration curve. So for a given mix, as long as the mixture proportions do not change, we can use this calibration curve, for the rest of the project. Now, in this particular case, let's say we are shooting for 3000 PSI in the pavement. We want to know when the pavement reaches 3000 PSI. So all we do is we go to the calibration curve and look for the go to the strength axes, and then from there draw a straight line all the way to the calibration curve and see what the corresponding maturity number would be. So in this case, it's 2200. So then what we do is we go to the field, the pavement in question, and then we put in a maturity sensor in there. And then all we do is just monitor the maturity number in the pavement. So again, maturity is nothing but product of time and temperature. The sensor is measuring time and temperature and is calculating maturity for us. So we keep on measuring or monitoring the maturity. And as soon as the maturity in the field reaches 2200 units, then the pavement has also reached 3000 psi. So so let me walk you through the process. Again, we cast a bunch of cylinders or beams, whatever strength you're looking for, and then put in a temperature sensor or a maturity sensor in one of the cylinder or specimen. And then as we obtain strength and maturity information, we plot a calibration curve. That's really all there is to it. The upfront effort is there a little bit, but once we have that information, we could use that information for a number of days to estimate the in-place strength of pavement or any structure. So in this case, here you could see that we made a bunch of cylinders, and it's me. I placed a maturity sensor in one of the cylinder, and I was activating the sensor. And as you could see here on the right-hand side, that's the temperature strength calibration curve that's being built. And then what we do is we go to the field and then instrument the sensor. So the picture you see on the left is Nikolai, one of our main technicians. He has in his left hand the maturity sensor that he was going to place inside the pavement there. He was making a small hole so that he could insert the sensor in there, behind a paver. And then, like I said, this technology can also be used on other structural applications too. So the picture on the right depicts a photo of a residential wall where we placed a maturity sensor. And then all we do is just monitor the maturity from these sensors. So in this case, it's me taking the readings of maturity. And as you could see for this particular picture on the left, the maturity that I see there is 3000 degrees C hours. So those are the units that we measure maturity in degree time and temperature, right? So degrees C hours. So then we go back to the calibration curve and look for 3000 degrees C hours of maturity. And then the corresponding compressor strength in this case is 4300 compressor strength. So isn't that cool? So any given time, as soon as we know maturity, we can easily estimate the in-place strength of the concrete. Now, we can also do the reverse, which is if we know the compressor strength we are shooting for, we could then estimate the maturity number that we should be shooting for out in the field. So just to summarize or recap the whole concept of maturity. So maturity is a two-step process. In the first step, we cast a bunch of cylinders, and then we break them at different ages. I've listed 1 to 14 days here. If you have early age, high early strength mixes, then you probably don't even need up to 14 days. You can even get away with 7 days. So it all really depends on the compressive or flexural strength that we are shooting for. And then what we do is we record the maturity readings each time a test is done, and then we plot the strength and maturity curve. So once we get the curve, then we would go to the field and instrument the maturity meter. Now, typically the maturity meter is installed towards the end of the day, towards the end of the paving day, because that's typically the section that gains strength the latest, right? So we want to see how that particular section has gained strength. So if that section has gained strength, that means the previously paved section must have also gained strength, right? So now there is an ASTM test method for this. It's ASTM CE 1074. Like I said, this test method has been there for a while. It's a very, very mature test method, and it's used widely, around the world. So it's a like I said, it's a mature technology. It's a great technology. It's being used, but it's not being used as much as it should be. So I did mention earlier on that we are following the Nursol maturity function. So what the Nursall maturity function really does is it's a mathematical function to calculate the area under the curve. That's all it really is. Now, if you remember, I mentioned about this temperature called datum temperature. So any temperature below the datum temperature, we just ignore it in our mathematical calculations. Okay. Now, traditionally, we assume that that number is minus 10 degrees Celsius or 14 degree F. But if you want to be more accurate with what you're doing, you can always within the ASTM test procedure, there is a process that you can follow to obtain the accurate datum temperature. To be honest with you, with the work that we do with our concrete trailer, we rarely calculate the datum temperature. Most of the time, we just end up assuming a number. For paving applications, again, I'm just talking from my experience, assuming a number would be just fine. So in terms of verification, so if you remember, we've talked about the calibration curve, right? So you prepare a calibration curve at the very beginning of a project, and then you use that calibration curve to estimate your compressive or flexural strength, throughout the project. Now, how long is that calibration curve valid? Now the important thing with maturity is the calibration curve is valid as long as your mixture proportions do not change significantly. So when I say significantly, what I mean by that is, if typical variability in your, typical production variability is okay, but let's say your cement source change or your fly ash content change, or your water content change significantly. Well, if those things have changed, then you have to redo your calibration curve. Now, in some states that do specify the maturity test method, they do require that the calibration curve is verified periodically. So basically what they do is they specify a frequency, and then test specimens are prepared in the field and a maturity meter is installed in them. And then these specimens are cured in the lab until the maturity index, which is the maturity number, reaches value corresponding to the required strength. Now, if the strength that's measured is closer to the strength that's estimated, then your calibration curve is good. So what I mean by that is, if the strength that's measured from the verification cylinder is within 5% of the estimate that's given by the calibration curve, then it's okay. We can continue to use the calibration curve. If it's within plus or minus 10%, we should be adjusting the calibration curve. And if it's beyond 10%, then we need to build a new calibration curve. Again, here are some slides graphically representing what that really means. So state of practice. This I think is the exciting part. So here you could see different sensors that are out there to measure maturity. I would classify them into two different types: contact-based and wireless. Okay, historically, under contact-based sensors, the photos that you see on the left where it says external recorders, those were what we used for many years. With these sensors, basically they measure time and temperature, but the actual recorder itself is left at the paving site. So, it's actually visible. The problem with this approach is sometimes they get run over, the sensors get run over by construction equipment, or people tend to steal them. And nobody uses these anymore. The good part with those is they're very inexpensive. You really would be losing a piece of wire every time you use these sensors. But other than that, they're extremely inexpensive. But then nowadays, most people are using the internal recorder ones, where the sensor not only records the data, but it can also store the data. We only attach the reader when we are out in the field to download the data or to measure what the maturity number is. Okay, and these sensors, like I said, they're widely used and they're pretty good. But the cool part now is, in the last, I would say maybe 4 to 5 years, we now have maturity sensors that are wireless based, completely wireless. So some of them work on Bluetooth technology, some of them work on cellular technology. The cool thing with this is, I mean, you can be sitting in your office and you could literally watch your concrete gaining strength, which could be maybe, 100 miles away. So the cool thing with this is not only is it remote, but a lot of the calculations that I mentioned about earlier in the presentation, everything is done by the software. So we do not need to, there's not a lot of work from the user side. So, again, I do want to emphasize that this is the new aspect of maturity, which is the newer sensors that have come into the market now really makes the whole process seamless and really makes it easy to use. Now, in terms of how many agencies have matured in their specifications. So recently a survey was done. Now this, I don't believe all the states have responded back to the survey, but the survey was done by the National Concrete Consortium. So based off of that survey, it looks like at least 18 states have matured in their paving specifications. Some of the states, I think, may have it as a standalone specification, but in some cases, it could be an option. So a contractor could either make beams or cylinders, or he could be making using maturity. So one of those two things. But as you could see, it is fairly widely used. But there are a lot of states that still do not use. Nevada being one of those. Now, if you remember, I was also talking about the datum temperature determination. In the states that do specify maturity, half of the states basically recommend that the contractor use a default number, either -10 or 0 degrees Celsius. And then in some states, they do require the contractor to determine the datum temperature. Again, all of that information is in the ASTM test method. So implementation examples. So I'm going to share with you a couple of examples of how maturity is really helpful, to really, talk about the benefits of it. Really, how does it actually work in the field? So this is a project that we were in. This is Reno, Nevada. This was almost 8 years ago when we visited Reno with our Mobile Concrete Technology Center. If I'm not mistaken, the opening strength for construction traffic is 550 PSI flexural strength. So what we did was we made a bunch of beams and then instrumented one of the beam with the maturity sensor. And then we broke the beams at different intervals of time, 1 day, 2 day, I think 3 days and 5 days. And then we also measure the corresponding maturity number. And using that data, we plot our calibration curve. So we know that 550 PSI is a flexural strength. So for 550 PSI flexural strength, using this calibration curve, we found that the maturity number for 550 PSI flexural strength for this particular concrete mix is around 820 degrees C hours. So then what we did was we went to the field and we requested the contractor to instrument a sensor in there, which she did. And then a few days later, we went and downloaded the data. And we actually put 2 different sensors on 2 different days. And as you could see, for the days when we put these sensors, the maturity numbers were almost identical. Now, if you remember the maturity number we got from the previous slide, it was 820 degrees C hours, right? So we looked at this data and we then found that for 820 degrees C hours, the corresponding time to reach that number out in the field is only 22 hours. So what that means is by the time it's 22 hours for this particular mix, the pavement has reached 550 PSI flexural strength. 1 day. Can you believe that? Just 1 day. So, and then here is another example. This is from Little Rock, Arkansas. We were there 3 years ago. The opening strength in Little Rock, in Arkansas, is based on compressive strength, 3,000 PSI compressive strength. We made a bunch of cylinders, and then again, just similar to what you saw before, we also built a calibration curve, this time with compressor strength instead of flexural strength. Now, one thing I do want to mention is you do see a bunch of cylinders there. I do not want you to, misinterpret or think that we really need to make a lot of cylinders to do maturity. The answer is no. Depending on how you do it, you can get away with, as little as 12 cylinders. But most people, do up to 15 cylinders, cast up to 15 cylinders. The cylinders you see in that pictures are also used for other purposes. So just want to mention that. So for 3000 PSI, for this particular mix, the corresponding strength or maturity number is 1500 degrees C hours. Now, in Little Rock, we were there at 2 different times. We went there in spring, and then we went there again in summer. And as you could see, the blue line, it represents when we were there in summer. Again, this is data from the field, and then the red line represents maturity from the from maturity sensor from spring, and green represents the standard cured cylinder. So for 1500 degrees C hours for the mix in Arkansas, in summer it only took a day to reach 3000 psi. In spring it took 2 days, versus more than 2 days for the standard pure cylinder. So again, as you could see, with maturity, the cool thing is it's also considering the impact of weather on strength gain, like we've talked about all along. So it's not like it will always give you one number. So again, this is the same data from Arkansas. The blue represents temperature, pavement temperature in summer, which is quite high, and then the red represents the pavement temperature in spring. So because of the difference in temperatures, we also saw differences in strength gain. Here is a picture or a slide that shows when opening strength was met in different states. Again, these states are at random, and this is data from our Mobile Concrete Technology Center. As we go across the country, we demonstrate it in different projects, in different states. So I just pulled this data from our database just to show you how opening strengths are being met a lot sooner than what we historically are used to seeing. So in this case, as you could see, Nevada actually, the project that I showed earlier on, the pavement reached a strength of 550 in literally a day. But even other projects, as you could see, in majority of the cases, the pavements reached the opening strength requirement in literally a couple of days. Michigan, which is a very far right corner bar, it says more than 100 hours. And that was because we were there in October of that year and the weather conditions were quite cold. So again, similar data. This is from Iowa. So benefits. Well, the biggest benefit that I see with maturity is that you're actually measuring the in-place strength of the pavement. You're not assuming that you break a cylinder or a beam and then assuming that number actually represents what's in the pavement itself. So I think that really is a big advantage of it. And of course, the other aspect is, it's easy to implement and the equipment is portable. And like I said, with this new sensors, things are even more easier now. The one thing I often want to keep, I often say, and people don't, okay, let me back up a little bit. Oftentimes I see that people think that cylinders or beams are very similar to the pavement or the structure just because of the same concrete. But just keep in mind, it's not necessarily the case. Your pavement is much bigger mass and it's being exposed to a wide variety of weather conditions versus your cylinders, which is much smaller mass, and especially lab cylinders or beams, right? You're curing them under constant temperature. So they're not really apples and apples. They're really apples and oranges. So, and finally, in terms of advantages, I think maturity really has a lot of advantages to offer. The biggest thing is really reduced construction time. So rather than waiting for 7 days or 10 days or 5 days, if you can open your pavement to construction traffic in only 2 days, wouldn't that be a lot of cost saving from the contractor? But that's also a good thing for the agency, isn't it? Because now you get the project done a lot faster, and public is happier. So everybody is happy. So one cool thing with maturity is, unlike a lot of other technologies, maturity is a win-win for both agencies and contractors. And of course, let's increase safety because you have less construction activity exposure. And then of course, the cost aspect, as I mentioned, it would be reduction in cost from a construction standpoint, both for contractor and agency. Now, from a consultant standpoint, right, it will also help in reducing the number of cylinders or beams that are made. So, again, it's a win-win in every aspect. Now, things to consider. Now, maturity cannot account for inadequate construction practices in the field. You still need to make sure that your concrete is consolidated properly, it's placed properly, cured properly, and all of those standard practices. So if you don't do those things, then of course maturity is not your problem. You have other problems, right? And then the other aspect, one of the important aspects with maturity is you want to make sure that you have, you do not have significant batch-to-batch variability in your, in your production. If you do, then of course, maturity would not work because you need to keep on building new calibration curves. So in summary, it's a great tool for measuring in-place length of concrete, early opening to traffic, so it will help us with fastening the construction, and it does help in reducing the volume and cost of QC testing, and of course it also has a lot of safety benefits as well. So that's all I have.
Thank you, Jagan. That was excellent. I appreciate all that. We have one question, and I do want to point over to that chat box again. And in that box, there's a Q&A tab that you can click on. And so if anybody has a question, they can go over there and type that in. And I'm just going to run through. We have two in there right now. So the first one, on the Reno project, did you also compare compressive strength to maturity results in the field?
We did not. We did run a bunch of compressive strengths. If you ever want to have the data, I'll be happy to share. But we did not do a companion compressive at different ages because Nevada DOT was more interested in flexural strength for maturity rather than compressive strength.
I guess there's that interest in correlating, the compressive to the flexural as well. So probably an interesting thing to do as you're implementing. Cylinders are pretty cheap, compared to flexural while that's happening. So, okay, let's see. We have another question here. Is this a valid concept for mass or structural concrete?
Oh, absolutely valid. In fact, I would argue that it's used more, a lot more in the structural side than on the paving side. We haven't really, used it as much as those guys.
Right, didn't it? It seemed like it was more mature in bridges and precast. I think that's really where it has emerged from, and now we're discovering it as a really good pavement tool as well.
Exactly. Yep.
I think that's all the questions I see. I'm thankful for all your support and hard work. With just improving things. I know you've helped us you've been in Nevada a number of times and you've been in California a number of times, and I'm thankful for all your support, Jagan. You're really helping improve the industry, and I think it's great to collaborate with people that have that same passion. So I'm thankful you're part of that effort, and thankful for your time today. So.
No, absolutely, Charles, and you've been a great partner. One thing I do want to say is, we were. I think we're in the midst of making some changes happen, and those changes won't happen without you and Nate's help. So I also want to say thank you for that.
You're welcome. Well, at that, I'd like to transition here and